everyone. Today we are going to present Encapsulating Security Payload, also known as ESP. ESP is an important part of IPsec protocol suite, which is used to provide secure communication over networks. Before understanding ESP, let us think about a real-life situation. Imagine you're sending a confidential message to your friend, like meet me at 5 p.m. Normally, when data travels through the internet, it passes through many devices and networks before reaching the receiver. During this transmission, someone may try to read the message, someone may try to change the message, or someone may pretend to be the sender. These are some of the examples of network security attacks. To solve these problems, ESP provides confidentiality, keeps the message secret, authentication, verifies the sender, integrity, ensures message is not modified. In our project, we created a simulation where one system acts as the sender, another acts as the receiver, and we also simulate an attacker to trying to tamper with the message. Now my teammate will explain the concept of ESP in more detail.
Now let us understand how Encapsulation Security Payload or ESP provides the security during the communication. ESP mainly works using the two important mechanisms, encryption and authentication. In our project, we use AES encryption to convert the original readable message into unreadable ciphertext. This ensures the confidentiality because even if an attacker intercepts the data during the transmission, they cannot understand the contents without the secret key. Along with the encryption, ESP also provides the authentication and integrity using the HMAC with the SHA 256. HMAC generates the unique authentication tag for the message, which helps the receiver verify whether the message was modified during the transmission. At the receiver side, the same authentication process is performed again, and if both tags matches, the message is considered authentic and unchanged. However, if the attacker tampers with the message, the verification fails immediately, showing that the data has been altered. Our simulation, we also demonstrate this attack scenario to show how ESP can successfully detect unauthorized modification and provide secure communication between the sender and the receiver.
Now I will explain the implementation of our ESP simulation using Python. We use a cryptography library for encryption and authentication. So these are the libraries. These libraries helps us perform AES encryption, HMAC authentication and random key generations. Next, we generate two keys, encryption key and authentication key. Now, the sender sends the original message, which is meet me at 5 p.m. and then generates initialization vector equal to os.urandom of 16, and then the ciphertext is generated using the AES algorithm. After encryption, plaintext becomes unreadable ciphertext. This provides confidentiality. Now for receiver side verification, if verification succeeds, message is authentic. If verification fails, then the message was modified. Step 6. Decryption. After successful verification, the receiver decrypts the message. Finally, the receiver gets the original message successfully. Now let us see the program output and attack simulations.
Okay, now I will demonstrate the output of our ESP simulation program. First, the program displays the original message which is entered by the sender. The original message which is entered by the sender is meet me at 5 p.m. Then the message is encrypted using this AES encryption method, and the encrypted ciphertext is shown on screen. This is the encrypted ciphertext. The program then generates an HMSC authentication tag which is used to verify the integrity and authenticity of the message. At the receiver side, the authentication process is performed successfully, and finally the encrypted message is decrypted back into the original message, which is readable message. This demonstrates that the ESP can securely transmit data between the sender and the receiver. Next, we simulate a tampering attack. In this step, an attacker slightly modifies the ciphertext during the transmission. Even though the change is very small, the HMSC verification process immediately detects it. When the receiver tries to verify the authentication tag, the verification fails and the program displays a message such as tampering detected, which can be seen here. This proves that ESP not only encrypts the data for confidentiality but also protects the message from unauthorized modification by ensuring integrity and authentication. Okay. Through this demonstration, we can clearly understand how ESP provides secure communication using encryption and authentication mechanism. Thank you.